All right, let's talk about some basic batteries. Just so you're aware, basic definition up here for a battery. The goal is to produce electricity by transforming chemical energy into electrical energy. And you're pretty used to this because you take your batteries and you put them in your electrical devices, and hopefully, as long as the batteries are fresh or whatever, they last for quite a while. But eventually, we know that they do run out. Why? Because the actual chemicals in them eventually start to decay away. Okay. Things that we want to understand about a battery, it comes by many different names. You might see something as an electric cell, or just plain cell, or electrochemical cell, lots and lots of cells. But these are the same thing as a battery. Pretty much this terminology is the same. Now I can tell you that a cell is usually just considered one particular part, one of these things. A battery is usually considered multiple things put together, but for the most part, it's going to be the same thing for us. Okay. Now, up here I've given a description of a pretty common battery. It says it consists of two different types of metals immersed in some sort of acid. The metals are known as electrodes, and then the acid's known as an electrolyte. Now, there's a whole branch of chemistry that deals with this kind of stuff. We're not going to get into the logistics of exactly how the chemicals are really working. I'm going to give you a very brief outline here. So, but again, it gets obviously more complicated than this at times. But if I've got two different metals and I immerse them in this acid, you might get one of those things where the acid dissolves some positive ions. Okay, so if all of a sudden you've got a bunch of positive ions in the acid, you strip the positive ions and left behind electrons. So one of these terminals gets negative. But with all the positive ions in here, off this terminal, it'll strip negative ions, leaving behind a positive charge on this terminal. So you get a negative charge and a positive charge. Now, when you have a buildup of positive and negative charges and they're a certain distance apart, we've developed a voltage or a potential difference. Okay. Now, on a normal battery, and I've drawn a D battery here, okay, you've got a positive terminal on the top and a negative terminal on the bottom. It's just the way that it's constructed so that you've got positive on one side and negative on the other. Again, it's just a way to create a potential difference, and actually the physical length of the battery will have something to do with the potential difference itself. Okay. All right, so on a circuit diagram, and we haven't talked about circuit diagrams yet, so this is kind of the first deal here. You're going to see circuit diagrams where these lines represent the wires, okay, and then a battery or a cell is represented by a long line and a short line. The positive sign always goes by the long line, and then the negative sign goes by that short line. It really doesn't matter, but that's traditionally the way it is. Usually if there's just one, they'll describe it as a cell. A battery will oftentimes have multiple of those cells put together. So you get a positive and a negative over there. This is trying to show you, like, if you put two double A's into like a remote control or something like that, that would probably show up, or that would be how it would look on, say, a circuit diagram. Okay, but either way, the deal is to build up positive on one side and negative on the other. So I've put here that the purpose of a battery is to produce a potential difference, or a voltage, which will make an electron move. Okay, by building up a positive on one side and a negative on the other, it's going to force electrons to flow through the wire. So a most basic type of circuit that I can draw. Okay, I've got a battery, and it's connecting a wire to a light bulb. Okay, so if we connect the wire to the light bulb and connect it to the battery, okay, what's going to happen here is if we build up, there's a positive charge built up on the battery, that's going to draw electrons. So electrons will flow through this wire, through the light bulb, and over to the other side. Okay, that flow of electricity, that flow of electrons, is going to actually light up the bulb. Okay. Now, I've written down here that sometimes it might be helpful to think of potential difference as a pressure. It produces a certain amount of pressure that actually is going to push those electrons through. Anytime you have a bunch of pressure, it feels like it's pushing, pushing, pushing. So sometimes it's maybe more helpful to think of potential difference as a pressure instead of, our basic definition of it. Okay? All right, so that's batteries.